Hello everyone, my name is Saj Pujan. I'm from the data science, and my topic is classification of iris dataset using based on algorithm in supervised machine learning algorithm. Let's move into the topic. Introduction to iris dataset classification, KNN algorithm. The iris dataset is a classical dataset in machine learning containing information about three different species of iris flower. So iris dataset is a data set and which is a machine used in the machine learning and contains about three different species. What are the species we see in this content? So KNN is a K-nearest neighbor algorithm. It's a machine learning algorithm and it is a supervised machine learning algorithm which is used for the dealer task for classification and regression task. In this presentation, we will explore the KNN algorithm applied to classify the iris datasets. To understand the iris data set contains of 150 samples and clear 150 samples and with 50 samples of each three classes. So there are 150 samples in each, and each for each sample, each class they are consisting of 50 samples. There are three classes that are Setosa, Versicolor, and Virgin. Each sample contains four features: sepal length, sepal width, petal width, and petal width. Its goal is to predict the flower based on the features. These are the four features. Based on these features, we are predicting the what type of the flower it is. Overview of K-nearest neighbor algorithm. K-nearest neighbor is a non-parametric and lazy learning algorithm. It classifies the new database with data points based on the majority classes of its K nearest neighbors. The value of K is a hyperparameter that needs to be tuned for the optimal performance. The K nearest neighbor is a simple to implement and the interpret, making it a popular choice for the classification task. So now it's task of for the classifying the species, and it is a K nearest neighbor is usually a algorithm for majority of the classes which are the near to the data points. Pre-processing the data set. Split the data set. First steps to implement the KNS name. Calculate the distance between new data and point and all the other data points in the data sets. Select the KNS neighbor based on the calculating distance and assign the class names to the new data points based on the majority of its class neighbors. So see here, it is an example for these are the data points. These are these class A, class B. These are the nearest. It's one of the point for the k nearest. Based on this point, we are selecting uh, the nearest neighbors for this pre-processing the iris dataset. So splitting the data sets into training and testing to evaluate the performance of the KNN algorithm. So we should for first we should be imported the libraries. After that we should import the data sets. After that we should split into the data sets into the tray for the training and testing. And then training it's be a ratio of 70 to 30 ratio. So standardizing the futures to ensure that each future contributes equally to distance calculation. Handling any missing or outliers in the dataset before applying the KNN algorithm. So before going to the applying the KNN algorithm, we should do some operation such as finding the outliers and missing values and identifying the null values. If it is a the dataset contains any missing values, invalid and null values, so we should do any operations on it, choosing the optimal value of K. So K is precision, recall, advanced for these are the all for the evaluating the algorithm. So it is a fit or not fit for the prediction. Using the cross validation technique such as grid search CV to find the optimal value of K. So using the cross validation technique such as grid search CV, is used for the finding the optimal value for the K. So evaluate the performance of the KNN algorithms. They're using K or using metrics, accuracy, precision, recall, and different scope. These all are used for calculating the optimal value of the K. So you based on these values, we are calculating the model. Select the value of K and use the best performance as the validation set. So based on the K value, we are performing the validation on the data set, training the KNN model on the data set. Fit the KNN model on the training set using the optimal value of K. Make predictions on the set to evaluate the performance of the model. Calculate the accuracy of the model and compare it to the other classification algorithms for the benchmark. So with the KNN model on the training set using the K optimal value. So what are these optimal value with the precision and recall accuracy, the metrics which we are using. So based on that, we are training the data set and then make predictions for the on the test data sets. So we are dividing the data sets into the two parts. What's for the training, another one is a testing. So uh, calculate the accuracy and precision and recall for the model evaluation. After that, we are training and the testing the data, evaluating the KNN model performance. Using the confusion matrix to visualize the true positives, true negatives, false positives, and false negatives predictions. So these are the confusion matrix. Based on the confusion matrix, we are evaluating the KNN model and other techniques such as calculating metrics like accuracy, precision, recall, and F1 score to evaluate the performance of the KNN model. So to evaluate the performance of the model, so we are using the accuracy, precision, recall. These are the things to evaluate the model and plot the ROC curve. Let's calculate the AUC score to access the model ability to discriminate between classes. And how to improve the model performance, improving the KNN model performance. Perform the future selections to identify the most important features for the classified. So first of the major task of the KNN to improve the KNN model performance. First, we should know the future selections to identify the most important features for the classification. Try different distance metrics such as load and these are the used for the basic data sets. Explore ensemble techniques such as bagging and boosting techniques to uh, improve the performance of the KNN model. Conclusion: the KNN can be effectively used to classify the iris dataset based on its features by tuning hyperparameter pre-processing the data, and we can improve the performance of the KNN model. Further research, they explore the techniques, advanced techniques to enhance the classification accuracy of the KNN algorithm on the datasets. These are the references. And the overview of the data, this video, introduction to data sets, classifying KNN algorithm. You know, the KNN is a uh, classification and regression performance. It is a supervised machine learning algorithm. First of all, the data sets containing of the three classes, and the each classes and each class have four features: sepal length, sepal width, petal width, petal width. These are used. This algorithm used to predict the what type of the flower it is. So it is a KNN is a hyper used for the machine learning algorithms to implement it. KNN is how to implementation of the KNN is the KNN select one point data point new data point that's and our the nearest neighbors can be distance calculated and find the majority of the classes for processing the data set. Data sets contain pre-processing the data sets nothing but is a when we see the data sets consist of the many samples, we should split the data sets into the two parts. One is for the training, another one is a testing. So based on this, we can predict in the output and choosing the optimal value of k is nothing but like model performance and we should use this cross validation techniques such as grid search theory and accuracy, precision, recall, and effort score. We are validating the data set and training the data set and the training is a much to evaluate the performance of the model and how to improve the uh, model. We are using the confusion matrix and like accuracy, precision, and recall. These are the things to evaluate the model performance. To improve the model performance, we are using the future selections and different stress metrics such as Euclidean and bagging and boosting techniques. So this is the conclusion for that. Thank you so much.